Hi GOR, this is Unit 8, Lesson 2, and today we're going to talk about slopes and perpendicular lines. Alright, so we saw in the last lesson that if I have two lines that have the same slope, they're parallel, but this time I have two lines that are perpendicular, and we're going to see there's a relationship between those slopes as well. So I know they're perpendicular because of that symbol right there. Alright, let's find the slope of the line. So the graph on the left, I'm going to find the slope of AB. So let me show you how you can do this either algebraically or graphically. So if you want to do it algebraically, you need the coordinates of A, and A is -6, -5. And you need the coordinates of B, and B is going to be 9, 5. All right, and then if I want to find the slope, I just do the change in Y, so 5 minus -5. And the change in x, 9 minus -6. So that is 10, because minus negative becomes a plus positive, and minus negative becomes a plus positive, so 10 over 15. And each of those are divisible by 5, and I get 2/3. Okay, that's a 3. And then I want to find the slope of CD. So let me do that in a different color just so it doesn't get too confusing. So C is the point -2, 6. And D is the point 6, -6. So again, slope, -6 minus 6. And then 6 minus -2. So that's -12 over 8. And those are both divisible by 4, so that gives me -3/2. So we can see my slopes are not the same, obviously. All right, let's do graph 2, and then we can talk a little bit more about what is true about their slopes. So graph 2, I'll just do graphically. So when I'm doing the slope of EF, I'm starting right here, and then I just have to see, so it looks like I'm going up 1 over 2, up 1 over 2. See how that's happening? Up 1 over 2. So my slope of EF is just 1/2. And you can go all the way from E all the way up to F if you want, and then you would just have to reduce that, of course. All right. And then the slope of GH, I'm starting here at G, and I just had to find another point. Looks like that's another point. So I'm going down 2 over 1. So that would be a slope of -2 over 1. Okay, so it is a little bit quicker to do it graphically. Just be careful that you're doing actual points. So we want to list as many observations as we can about these slopes. Well, notice in both cases you got one positive and one negative. And there's also something that's true about the numbers themselves. So I have 2/3 and -3/2, and 1/2 and -2 over 1. So those are just reciprocals of each other. So we say that they are negative reciprocals. All right, so slopes of perpendicular lines, and again, I have to put in that stipulation that they are neither vertical nor horizontal, but the thing you want to remember is the slopes are negative reciprocals. Again, I have to say that they're not vertical or not horizontal because those technically, vertical lines don't have any slope, and horizontal lines have slopes that are 0. So technically, the slopes are not negative reciprocals for vertical or horizontal lines. But for all other lines, all right, the slopes of perpendicular lines, the slopes are negative reciprocals. So that's what we need to remember from that. All right, so I have line segment AB has points A and B. Which of the following would be the slope of a line perpendicular? So let's first just find the slope of AB. And again, if I want to label these, x1, y1, x2, y2. So I'm going to subtract the y's, that goes on top, 15 minus 7. And I'm going to subtract the x's, that goes on the bottom, 3 minus -3. So that's 8 over 6, both divisible by 2, so I get 4/3. Now that answer's there, and it's actually choice 1, but that is not my answer. I want the slope of a perpendicular line, so the perpendicular slope, first of all, I got to change the sign. That's positive, so when I change the sign, it's negative, and I have to flip it. So change the sign and flip it. And there's my answer, choice 2. Okay. Number 3, if a line was drawn through point C in the diagram such that it's perpendicular to AB, at what coordinate point would the two lines intersect? So again, I have to find the slope of AB, and then I want the perpendicular slope. All right, so if I'm looking at AB, it looks like this is a point, and it looks like this is a point. All right, so I'm going up 2 over 3. So AB has a slope of 2/3. So my perpendicular slope is going to be negative, because I got to change the sign and flip it. Now my top number tells me to go up or down, and my bottom number tells me to go left or right. So from that point right here, I'm going to go down 3, 1, 2, 3 over 2. And I'm going to go down 3, 1, 2, 3 over 2. Now I want to see where they're going to intersect. So the opposite of going down 3 to the right 2 is to go up 3, 1, 2, 3, and to the left 2. Up 3, 1, 2, 3, to the left 2. And there's my line. Let me draw that. And then, oops, I want to see where they intersect. So the coordinate, the point where they intersect is right here. And that is 1, 2, negative 3, 3. Okay. All right, so because of the role of right angles in figures such as right triangles and rectangles and perpendicularity, the concept of perpendicular lines and their slopes being negative reciprocals is going to come up a lot. So the simplest test with slopes will help us determine if the right angles are present. So in exercise 4, I want to know if AB is perpendicular to CD. Look at that perpendicular sign right there. Okay, so I want to know if AB is perpendicular to CD. So this one I'm just going to do algebraically because I already have my points right there. So slope of AB, I'm taking these 2 points, 4 minus negative 5, 1 minus negative 2. That's 9/3, which is 3. And then I have to find the slope of CD. So I'm going to do these 2. So 4 minus 6, 5 minus negative 3 is negative 2/8, which is negative 1/4. All right, so if you're looking at these, they are not negative reciprocals. One's positive and one's negative, but they're not negative reciprocals. So are the lines perpendicular? They are not perpendicular. All right, the slopes are not negative reciprocals. And then in this last problem, I have triangle ABC, so I'm going to graph it. All right, it says the use of the graph is optional but advised, and that will be the wording that you will see all the time on the regions. So negative 5, negative 7, that's A. You can see that every fifth line is colored in a little bit darker, so it makes it a little bit quicker to graph these. 7, negative 3 is B, which is right here, and C is 4, 6. So I'm just going to connect those to make my triangle. You can graph it too if you'd like. The benefit to graphing it is you can see where it looks like the right angle is. I want to know if it's a right triangle. If it's a right triangle, it has a right angle. Now, where does it look like it has a right angle? It looks like it's a right angle at angle B. So I want to test to see if CB is perpendicular to BA, because it looks like the right angle is at B right there. So I'm going to find the slope of CB, and I'm going to find the slope of AB. All right, so let's do CB first. Just make sure you're doing CB. 6 minus negative 3, 4 minus 7, which is 9 over negative 3, which is negative 3. And slope of AB, again, subtract the y's, negative 3 minus negative 7, and then subtract the x's, 7 minus negative 5. So minus negative is a plus positive, and again on the bottom, minus negative is a plus positive, and this is 1/3. Yep, it is a right triangle because AB is perpendicular to BC, or CB, it doesn't matter which one. How do I know that? Slopes are negative reciprocals, right? One's a positive, one's a negative, and they're also reciprocals. They're just inverses of each other because this is really negative 3 over 1. So triangle ABC is a right triangle. This is called a coordinate geometry proof. All right, totally different than the other proofs that we did before. It's a coordinate geometry proof, and they're much easier. We use the coordinates and we use slope formula, and we're also going to learn midpoint and distance formula, so we'll use all three of these to do our coordinate geometry proofs later on in the unit. So we'll practice this slope tomorrow and perpendicular lines. The key thing to remember is perpendicular lines, the slopes are negative reciprocals.